I'm Nuno Henrique Franco, and with this talk, thinking about animals' lifetime experiences and cumulative severity, I will try to make the case that a good life is possible for laboratory animals, and that even when a good life is not possible, we can provide a life worth living. Also, I will stress that if a life worth living is not possible, then animal use should not be admissible. But what is a good life? Is it a stress-free life? Or perhaps a pain-free life? Of course not. A stress-free life would neither be possible nor desirable, because boredom is actually a welfare problem, and that goes for both us humans and other animal species, including laboratory animals. So avoiding de-stress should be the primary goal. One may have suffered transient hunger, discomfort, pain, or fear, and still have had a good life. So it is one's whole life experience that will determine whether one had a good life. And even those who have endured dire circumstances such as chronic disease or difficult childhood can sometimes say they had a life worth living if, looking back, the balance between their positive and negative experiences is favorable. And this begs the question, can laboratory animals have a good life? Well, what a good life would be for laboratory animals in absolute terms is quite hard to know. However, in relative terms, we can compare their lives to that of wild animals. And most wild mice die when they are pups or juveniles. Death causes include predators, competitors, disease, malnourishment, or cold, among other factors. Those that do not die at a young age will suffer constant challenges just to be able to survive throughout their whole lives. Let's look at another example. Even though stray dogs can go wherever they want and do whatever they please, they endure considerable hardship throughout their whole lives. This includes hunger, disease, heat, or cold, whereas my own dog, for example, lives a very happy, comfortable, healthy life, even though she doesn't get to decide where she lives, when she can go outside, or what food she eats. And what about laboratory dogs? Well, depending on the conditions, lab dogs may or may not have a good life or life worth living. For example, you can see the contrasting conditions between the dogs on your top right corner and in your bottom right corner. The dogs above have ample space to play, they have each other to interact with, they have toys, and they can go outside. Whereas the dog in your bottom right corner is quite evidently much worse off, and you can see that his conditions are not the best. The cage is quite barren, and he can't go outside, and there are no toys to play with, and the space available is actually also quite small. So, returning to the question, can laboratory animals have a good life? I believe so, in some cases at least, even though this might be controversial. And even when a good life is not possible, animals should be allowed a life worth living by balancing their 5 freedoms, which I'm sure you all know, with the goals of research. It is my view that if animals suffer pain and distress for most of their lives and up until they die, that their lives were not worth living. And also, in my view, allowing a life worth living should dictate whether a scientific use of an animal is even ethically admissible. And even if most lab animals are better off than most wild animals, we have a moral duty towards the animals that are under our care and responsibility, and hence to ensure them, at the very least, a life worth living. How can we achieve that? Firstly, we must consider the intensity and duration of the stresses we allow animals to endure. If animals are allowed to fully recover from stressful events, the stress is avoided. Also, you have to bear in mind that typical laboratory animals are quite stoic, meaning that they will attempt to mask signs of weakness. And signs of poor welfare may manifest only after the animals have been distressed for a considerable period. So, we should avoid subjecting animals to severe or prolonged stresses. We should plan and schedule our procedures to allow recovery time to the animals. Apply refinement as much as possible and monitor the animals regularly. Learn from previous studies to improve on future ones. And finally, for animals with long lifespans, we could consider retirement, which would mean rehabilitate and rehome the animals after their scientific use. If we are to avoid de-stress, we should mind the intensity and the duration of whatever stresses we are applying to the animals, because prolonged or severe stress will deplete the bodily reserves affecting normal functions, and more time will be needed to revert to homeostasis. During this recovery period, the well-being and welfare are compromised, and the distress will ensue until biological resources are sufficiently replenished. To illustrate the importance of allowing animals time to recover, let's look at the stress caused by a very simple procedure, an IP injection. This is what we think is happening. So prior to the injection, the animals are undisturbed in their home cage, they are in homeostasis, they are well. During the IP injection, we restrain the animal and inject it, and then we return it to the home cage. And afterwards, because the procedure only caused acute mild stress, after a while, homeostasis is resumed. But is that it? But actually, there is a lot more going on. Firstly, when we remove the cage from the rack, we cause noise and vibration. The researcher or the technician are perceived by the animals as a stressor. Some water may drop from the bottle, possibly over some animals. And then we open the cage lid and we expose the animals to bright lights and louder noises, some of which we cannot even hear, including the air conditioning. Also, many different smells. Some of them are noxious. This includes cleaning products, alcohol, or blood. And this is important. If this is a procedure that the animals know is repeated, let's say that the researcher does it every day, anxiety may rise from the previous negative experience. And then we do the injection. And what does this involve? We've removed the animal from the cage, we lift it in the air, which is quite an abnormal experience, and the animal is separated from the cage mates, and it may send distress signs. We restrain the animal, so the animal is helpless, and then we cause the pain from the needle injection, and the following animals will be even more stressed. In this graph, I present results from my own work. The hypothermic stress response is a rapid increase in body temperature in response to a stressor. And we use this to evaluate if a procedure has an impact on the animals and of what magnitude. All animals are subcutaneously implanted with a thermosensitive sensor, and temperature is read at a distance. We compared animals that remained undisturbed with others that were just picked up and returned to the cage, others that were picked up and had their cage changed, and others that had their cage changed with some of the original bedding in the new cage. In all of the animals that were disturbed, we observed a very significant rise in body temperature. At 10 minutes, the mean difference between disturbed and undisturbed animals reached 1.5 degrees. We didn't find any differences between animals that were just picked up and returned to the cage and those transferred to a new cage. And importantly, these differences persisted for 4 hours. So how can we reduce the impact of stresses? Well, a major component of a stressor is its uncontrollability and unpredictability. So training and conditioning animals to experimental procedures reduces anxiety and helps prevent procedure-related distress. On your right, you can see a macaque presenting voluntarily its leg to receive an intramuscular injection because it knows it will receive a treat afterwards. Also, to minimize uncontrollability and unpredictability, we should acclimatize animals to the room where the procedures are to be conducted, familiarize them and the handler before the experiments, avoid changing handling schedules, give positive reinforcements whenever possible, so Nutella or a sucrose solution, and as in the example that I just shown, train the animals to cooperate with substance administration or blood collection. An effective way of reducing the impact of stresses is refining the way animals are picked up and taken out of their cage. On your left, you can see the traditional tail picking technique by which one picks the animal up by the base of the tail. It is quite obvious that the animal does not like it because it attempts to run away. This has been shown to have a long-lasting negative impact. One way of improving this is by replacing tail picking by a less noxious technique, in particular the use of a tunnel. With tunnel handling, even though the animal is not offered a choice in regard to whether or not to enter the tunnel, the animal can choose when to enter the tunnel, thus removing one of the key components of a stressor, which is its uncontrollability. You can see that the animals are much more keen to enter the tunnel than to be picked by the tail, which shows us it's a much more refined and animal-friendly technique. On your right, yet another refinement. Orogastric lavage has a huge impact on animals. You have to pick them up, restrain them, and then insert a cannula down their esophagus. But you can deliver a precise amount of a compound through an inert pill, which is the example of the pill system developed by one of my colleagues, which is readily consumed by the animal. We all know that environmental enrichment and social housing are important for animals, but one of the reasons they are important is because they can help mitigate or even reverse the impact of minor and sometimes even major stressful events, acting as a stress buffer. However, not everything that we add to a cage is enrichment. To successfully help animals cope with confinement and other stresses, environmental enrichment must be biologically meaningful. So far, into our knowledge, the single most important enrichment for rodents is providing nesting material. Also, it has been shown that without nesting material, laboratory mice may feel chronically cold, which of course affects our ability to provide them with a good life. To finalize, arguably the most relevant means of preventing unnecessary pain, suffering, or distress is the use of humane endpoints. These consist of the timely euthanasia of animals in earlier stages of disease progress to prevent predictable, avoidable suffering. And whenever severe suffering is avoided by use of humane endpoints, this can mean the difference between animals being able to live a life worth living or not, even if a good life is not possible. On your right, you can find 3 references regarding my work on human endpoints and some reflections on why I consider them to be the single most important refinement, especially in models of disease. Thank you all for listening.